Hi everyone, my name is Raina Ghazi and I am the Teacher Development Manager for Macmillan Education International Curriculum. Today we will have Mohi Uddin, who is our Singapore Maths Consultant, delivering a session focusing on fractions. If you do have any questions, please feel free to write in the questions box that you see. Other attendees won't be able to see each other's comments, so please just bear that in mind. Also, just in advance, if you are looking to have a CPD certificate, please do email at the end of the session as they are not automatically generated. And there will be a recording of this webinar available on our Macmillan Education International Curriculum YouTube page that will be made available this week. So for now, I'm going to hand it over to Mohi and he will be delivering the session. Thank you.
Hi everyone, hopefully you can hear me. I think Raina might have mentioned that you can actually communicate with me through the questions box. So if you see somewhere on your screen there's a questions box, you might have to click on the arrow and something pops down. I think some of us have written a message or two already. So hello from Odessa. So hello Helen, I think it was Helen. I could just about move that across. Yep. Hi, Ellen. If you want to just make sure that you can hit, if you can just let me know that you can hear me by writing a question down, just to say that you can hear me, so I can see a few of you writing it down now, which is perfect. That would be great. Can everyone hear me? Okay. Yep. Sounds good. Okay. So. Brilliant. So we've got lots of responses now, which is amazing. So webinars are quite a challenging task sometimes. So what I would really appreciate is any time that I ask a question or anything you've got on your mind, if you have your own question, if you can just write it in the questions box, and that way I will hopefully be able to see it because it's quite small on my screen too, and that way I can respond to you. In a normal seminar or a CPD session in your school, it's quite easy for the presenter like myself to see your eyes, your face, and see your reaction. But as an online CPD session, I can't see your face. So that questions box really helps me. So I think it's about 1:30 now, just a minute or two past 1:30 now. So we're ready to go. So I'm going to start off our session, and if you have any questions, like I said, you can always ask away in the questions box. So let's get going. So let's look at the content of today. So we're going to go through a few things on fractions today. Today's session is called Fractions Mastery or Mastery in Fractions, and it's about an hour long. So we're going to try to go through as much of fractions as we can in that hour. So firstly, looking at introduction to fractions, getting the basics right, and seeing and doing supports understanding, as well as making something that's quite complex. How can we make fractions, which is quite complex, simple? And then we can have a Q&A session. One of the things that I'm doing now this year from September, I'm actually teaching my own son at home. So we do homeschooling now with him. And this, from last week, actually, from middle of last week, we've been looking at fractions. And so, I've got really close experience this week of going through fractions using the strategies that I'll be talking about in today's CPD session as well. So the first question to you to think about is, what is a fraction? Okay, can you think about that for 30 seconds to a minute? If you've got colleagues near you, you can ask them, what they think, and then if you can type in your answer in the questions section, and then I can go through what you feel a fraction is. Okay, so I've got someone's written brilliant. It's a part of a whole. Okay, so a lot of us saying a part of a whole. Great. And Annazette Hudson says a part of a whole as well. Anything else? Any other responses apart from a part of a whole? Does anyone have anything different to say? I'll wait for a few more seconds to see if there's any other responses. Dividing a thing. Marina says dividing a thing. So there's a few responses there. Right, so you've got lots of parts of a whole. Part of a whole which consists of two numbers, the numerator and denominator. Thank you, Arshia. Ratio says Mustafa. Lizu says pieces. Okay, great. So brilliant. So we've got lots of different responses now as well. Okay, okay. So let's go back to our presentation. So the question is, what is a fraction? Now, I'm quite fortunate enough to deliver this type of CPD session all around the world, not just online, but in schools and in major seminars as well. And this is a question, when it comes to a fractions CPD session, this is a question that I would regularly ask as a first thing. And typically, most of the responses that you've given me so far is what I would expect in a CPD session, whether it's online or offline, face to face. And here, you won't be able to see are some responses from groups of teachers. Um, some responses from groups of teachers. Charu says my voice is breaking up, so hopefully you can hear me. It shouldn't be that bad. My internet connection is very good, but do let me know if it gets worse. So we can see that this is a response from some of our teachers. You might not be able to see the responses, so I'm going to be going through what they say. So here it says a fraction is an equal part of a whole. A fraction is a part of a whole, and many of the actual solutions have said part of a whole or portion of a whole, a part of a whole into equal parts. And that's one of the key things about fractions that we have to realize. Fractions are not just part of a whole. What we have to realize is fraction, and the key word here is equal part of a whole. A fraction is an equal part of a whole. So when we talk about 1/6 as an example, it just doesn't mean 1 out of 6 parts, it means 1 out of 6 equal parts. And that word equal is something that we have to stress to our children every lesson, whether it's the beginning of fractions or if we're nearing to the end of fraction in your phase, we still have to keep reminding them that is equal part of a whole. And without that, things in fractions like addition, subtraction, they become a lot more challenging. And so let's have a look at this now. So here's a question. Okay, so excuse me. Here's a question. I've got this piece of paper in front of me. Hopefully you can all see a red piece of paper in front of you too. I want to share this paper equally amongst two people. Can you share the paper equally amongst two people? How many different ways can you do that? So I'm going to give you about a minute or two. In front of you, you might have some paper, or you might imagine how this would look like. I'll give you a minute or two just to try that out, because you might think of the obvious solutions. Sharing this between two people, how would I share it? You might think of some really obvious solutions, but can you think of some solutions that might not be so obvious? Can you think of something that no one else may think of? Have a go at that. I'll give you a minute or two just to kind of draw out pictures on your side and see how you get along. If you want to write any questions, feel free to write away. Okay, so we've got some solutions: vertically, horizontally, diagonally, diagonal, 4 different ways. So some of us are getting the obvious ones, things that I would expect most children to be able to get, right? You've got 3 6 each, 5 10s each, a half each can be divided as many even parts as possible, says Lizu. Okay, well done. We're getting a bit more interesting now, right? So some of us are saying that we can we can share this out in different ways. So some of us are saying, okay, let's go diagonally, something like that. Okay, diagonally, great. How do we know they're two equal parts? Maybe we can fold the paper. So for example, I might be able to do something like this. I've got my paper in front of me. Hopefully you can all see that. I might be able to fold the paper like so. So some of us are saying vertically like this. Some of us are saying horizontally. So let's show you another one. So I've got a piece of paper. I might do it horizontally. So it looks like this, vertically, horizontally, diagonally, like the picture that we've seen. How do we know that these are equal parts though, right? How do we know they're equal parts? How many equal parts are there? There are two equal parts. How do we know they're equal? Oh, because when we fold them, you can see that there are two identical pieces. Okay, so we can fold them and find out how they're equal. That's one way. But some of us saying there's only four ways. So you've got 1, 2. I'm guessing you're thinking 3 and 4, right? But there are many ways, like some of us have pointed out in our answers, in our questions rather. So some of us may actually fold this again. Some of us may fold this again, and not only once more, but you might fold it again like so. And fold one more time, and we might have something like this, which might not be very clear to you. Okay, so what I'll do, I'll draw it out. So some of us may have folded the piece of paper like so, fold it again, and then fold it again and again. We have lots of pieces now, and we might actually come out with there are 16 pieces altogether. So I have to share 8. So I might come out with sharing 1, 2, 3, 4, 5, 6, 7, 8. I might share this shape here. So I have a shape that looks like this. And another shape that does not look like that. I have two shapes here, but they are still shared out equally. Can you see that? Is that okay? So I've got 8 pieces. I won't draw all the 8, but you can see how I've got 8 pieces. I've got 8 pieces of those small pieces in each of those shapes. But one mistake that we make quite regularly as teachers is say to the children something along the lines of, if they look the same, they're equal. Can you see that these two shapes here, shape 1 and shape 2, they don't actually look the same, but they are still equal. So this is an exercise. So if you attended our previous webinar last month, we talked about anchor tasks, and this could be an anchor task for you at the beginning of your fractions lesson, where we talk about equal parts. Now, we definitely won't expect our children to come up with solutions like these if they're really young, but they can come up with the solutions that you've come up with. But some of the children may come up with some very interesting solutions that maybe you haven't thought of. But we have to be very careful with the language that we use. We have to say equal parts, firstly. And secondly, we have to determine how do we work out the equal. Maybe with an example like the one that's on the screen now, we can cut out each piece or count each piece and say there are 8 of those equal small squares. So they must be shared equally. But the language we use when we say if they look equal, they are equal, that's not correct, because we can see by this example that they are equal, but they don't look the same. In the books that we have, the Macmillan Max Maths books, you can see that we've gone through an example similar to the one that I've just shown you, where the anchor task is here, Let's Learn section, and we ask our children to maybe fold a piece of paper to try to share equally. Just take a square piece of paper and fold it in half as shown below. How many parts do you see? Are they equal parts? These are questions that as a teacher I would want to ask them. Then it goes on to these types of questions. Can you see why we might have gone to those questions? Because some children just think that if there's two parts, what did we say when I asked you what is a fraction? Quite a lot of us actually came up with some solutions, right? Let me remind myself again in the question section. Quite a few of us have said that a part of a whole, okay? So this is a part of a whole, but is it an actual half? There's two parts. Does that mean it's half? No, because they have to be equal parts of wholes, right? So that's something that we have to be really careful with as teachers when you teach fractions. Our visual representations that we have in front of us should allow our children to see the maths and see very clearly why something is a half or a quarter and why it's not. And if we show visual representations like these, all of these in our books, if we show these visual representations either as drawings, either on paper like this, physically, or from the books, then what happens is our children build a picture of what it means to play with fractions, what it means to have a half, a quarter, and so forth. And you can see that the book follows on, and it doesn't just go for your typical rectangular shapes, then it starts to challenge our children into thinking about triangles as well from the same square piece of paper. So this is a challenge that we face. We've got quite a lot to think about when it comes to fractions. And the thing that we don't do very well is try to cover all of the angles in fractions, because either our schemes are not strong enough or our plans neglect some sections of fractions. So here's a question I want you to think about. Represent half using 4 different models. What does that mean to you? Have a think. Represent half using 4 different models. Have a go at that. Give you another minute just to think about that and have a go. And then we'll come back together in 1 minute. Don't forget to write down your solutions in the show answers or questions section, questions box, so I can read what you are saying. So circles, squares, ovals, triangles, but they're all one shape, right? As in one circle, one square, one oval, one triangle. So one of our colleagues has said that we can represent half using 4 different models, but the models they've given are circles, squares, ovals, and triangles. But that's just one model, right? One model is half as part of a whole. So one way is half as part of a whole. What other ways can we model a half? 2 quarters. But again, in what's the model? 2 quarters of what? What's the model we were thinking about? 30 seconds. Bit more challenging question, this one, to kind of think about. Part of a set. Okay, Anna Z has said part of a set. That's a second model. So our first model we can have is part of a whole. Our second is part of a set. What about our third and fourth? What do you think? A third and fourth, what do you think? What other ways can I model a half? So a part of a whole could be like a circle. Oops, that's not a great whole, but I'm trying to draw it, part of a whole. So a circle, and we try to, this is a really bad example of a whole, but a half, sorry, but you can get my drift, a part of a whole. Part of a set might be, I don't know, you can have an egg box, and in England, we have typically 12 eggs in a box of eggs, and so you can think that, oh, here's 6 eggs that are half of the 12 eggs. So that's part of a set. What else is there? So part of a set, part of a whole. We can also have on a number line. So you've got, let's say, 0 and 1 here. So on a number line, that's a half. So another model is a number line. Do we use number lines when we think about fractions? When you're teaching fractions, as I know all of us are teachers here now, so when we're teaching fractions, do we think about number lines to represent? So that's something that we need to think about. Decimals are not fractions, but I know where you're coming from there. So number line, what else is there? Part of a whole, and also someone's just written down as well, division as division. So 3 divided by 4 can be written as 3 over 4 as well. Okay, so these are your 4 ways that you can represent different models for you to represent fractions, or in this case half as well. Here's an example from our books that covers not all of those 4, but you can see that there's a number line here, part of a whole. So depending on the year group that you're teaching, the age group that you're teaching, you'd look at some of these at certain age groups. So number lines, part of a whole, and then maybe later on you'd also look at other aspects like part of a set, and division would probably be at the latter stages of a primary education. Here's a question I want to think about as well. Seeing mixed numbers, how many wholes do you see here? You can see 1 whole here, 2 wholes here, and 3 wholes. There are 3 wholes in the picture you see in front of you. Okay, what about now? How many halves do you see in front of you? I can see 1 half. I can see 1 half. 1 half here. And I can halve these, 2 halves, 3 halves, 4 halves, 5 halves, 6 halves, and 7 halves. There are 7 halves. Can you see how 7 halves is equal to something else? If I get rid of the halves, what do you see now? I can see the 3 wholes that we saw in our last picture. That's a whole, that's another whole, that's another whole, 3 wholes, and I can see a half. So 7 halves are is equal to 3.5. A lot of us might not actually write down 7 halves in this way to represent a picture that looks like this. And that's a really challenging aspect of what I do, which is the training and consultancy for schools, is that we sometimes just jump without seeing any of these pictures. We just jump to 7 halves are equal to 3.5. What do we do, class? We divide 7 by 2. 7 divided by 2 is 3 wholes. We have 1 remainder, and that's 1 half. We might say something like that in our class, right? But for a child, that doesn't mean much. We're trying to memorize what you're saying, but we can't see what it actually means. And so drawing pictures of fractions is such an important part of learning, and it just helps us to understand. And that's where the Maths books really help and support our teachers, because when we talk about mixed numbers, for example, like these in the picture or in the pages in front of you, you can straight away see what we mean by 2 3/4 of a circle. You can straight away see what 3.5 may look like. We can straight away represent 2 1/4. And so when we can do these kinds of visual representations for fractions, that means when we ask our children questions, quite challenging fractional questions, it's easy for them to answer those questions either by being able to visualize it, seeing it in their mind somewhere, or for them to be able to draw out pictures. And I'll show you some of the pictures that we've looked at in this week and last week with my son, but also what many schools look at in the same kind of way. If you've got any questions, please feel free to ask away. We're around about halfway through our session, so I'm going to move on. Have a go at this question. 3 1/4 take away 1.5. I know that you can all do this, okay? But the key question for me, for you as a teacher, is this: how many different ways can you solve this? Okay, so the question I'm asking you is how many different ways can you solve this? So I'm going to write a message. How many different ways? How many different ways can you solve 3 1/4 subtract 1.5? So I'm going to give you 2 minutes. Send that to everybody. I'm going to give you 2 minutes to try to go through that. And once you've gone through that, type in, not your solution. You can type in your solution. You can type in your answer too. But I want you to type in what strategy you used, okay, in the questions box. What strategy did you use to solve this problem? And then we're going to go through it together to show you how powerful our strategies can be. So give you, let's say, what's the time now? Give you 2 minutes. I'm going to turn my camera off for this and I'll leave my camera on so you know I'm here, and I'll give you another 1.5 minutes just to come up with different solutions. So some of us are saying changed mixed numbers to improper fractions, and Nazette, well done. That's one way, right? But then what other solutions can you come up with? Is it just that one way, or are there more than one way? So we've got a few different ideas now. Okay, I'll give you another minute just to think of maybe any other ideas. Okay, just another 30 more seconds. Okay, getting some really interesting ideas now, which is brilliant. Okay, so let's stop there. I think just about squeeze 2 minutes there of your time. Okay, so we've got some really interesting ideas. So some of us saying convert, find lowest common multiple and subtract. Some of us are saying improper fraction. Some of us saying take the whole away. So let's go through like maybe two different solutions, okay? And bear with me with these ones, okay? So the first solution that we were kind of suggested was to make these into improper fractions. So we've got 3 1/4, and improper fractions means I can multiply 3 times 4 is 12 plus the 1, so that's 13/4. And I want to subtract 1.5. Now 1.5 will be 1 times 2 is 2 plus the 1, 3/2. So 13/4 take away 3/2. So we've made them into improper fractions, but we have to do one more thing, right, before I can straight away subtract, because we've got halves and we've got quarters. So I can find the equivalent fraction here. So 13/4 take away, this would be 6/4. 6/4 13 quarters take away 6 quarters, 13 take away 6, that means 7 quarters. So we're left with 7 quarters, and then 7 quarters is equal to 1 whole and 3 quarters. Is that right? Have I got that right? I think I've got that right. Or is that 1 whole and 2 quarters? I don't know. Let's see. 4, 5, 6, 7. 1 whole and 3 quarters, right? Some of us saying 1 whole and 2 quarters. So, okay, so, oops. Sorry, here we go. So 1 whole and 3 quarters. So our answer is 1 whole and 3 quarters. Our first method, method 1, was to show this using an improper fraction method. Okay, are we all happy with that? Let me know in your questions that you're all happy, that you understood what happened there. Okay. Now I wanna use the same approach, but remember the Singapore Maths approach that we use with our Maths series of books. It really focuses on understanding. So we really want to understand what's going on in this whole solution, because this is a really important solution, but we need to make sure we get why it works, or how it works rather. Okay, so some of us suggested that maybe draw a picture. Okay, so let's draw a picture. That's 1 whole, that's 2 wholes, 3 wholes, and I've got a quarter, right? So let's say something like that, and I can draw something. Just about maybe get away with that. Okay, so I've got 3 1/4. So the first thing we talked about is maybe thinking about, so we looked at converting into improper fractions and also converting into quarters. Can you see here? These are all quarters. So why don't I think about these 3 wholes and a quarter? I can see there's already a quarter here, right? There's already a quarter here. So why don't I think about converting these into quarters? So I've got a whole here. That's my 4 quarters. That's my another 4 quarters, and I've got another 4 quarters here. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I've got 13 quarters. Can you see where we've written 13 quarters before? We've written 13 quarters here. I need to take away 1 whole and a half. This is what I need to take away. So I know 1 whole is this. 1 whole and a half is here. I've taken away 1 whole and a half, which is equal to 4, 5. That's equal to 6 quarters. I can see that, right? And that's where I've written 6 quarters here. After I've taken away 1 1/2 pizzas, or whatever you want to call this, cakes, I'm left with 1, 2, 3, 4, 5, 6, 7. I'm left with all of this, which is 7 quarters. And I can see actually 7 quarters. This is my whole. That's 1 whole. And I've still got 1, 2, 3 quarters. So that's my 1 whole and 3 quarters. So I'm left with 1 whole and 3 quarters. Now, it's a lot more messy on my screen, right? Because we don't have as much space to kind of write everything down clearly. But hopefully you still get that. Can you see the power of drawing a picture to represent quite a complex strategy, which is improper fractions? Because with improper fractions, first we have to convert to improper fractions. Then we have to convert to equivalent fractions. Then we have to subtract. Then we have to convert the improper fraction into a mixed number. That's quite a few techniques rather in that one strategy. But looking at the picture, things can be a lot more simpler from something that's very complex. What we want, the ambition for me, is not just for my children to be able to understand the maths and see the maths, but for them to then be able to do this. So what we've just done, the complex part, which was the abstract maths, we want them to be able to do that as well, right? And that's the important part. So we're not just drawing pictures for the sake of it, for them to make it easy for them. We're doing that, drawing the pictures part, so that they can solve and be able to confidently solve questions like this using the abstract method. Because sooner or later, they're going to get bored of drawing pictures. But then all of that knowledge, that understanding that you've gained from drawing pictures will be used and utilized in the abstract method. Okay, that's method 1, okay? We've got a few other methods that we want to go through. So let's look at that. let's see if I can clear this screen a bit quicker. Okay, let me just see. So we've got method 1 there, and I want to look at method 2 as well. Okay, so let's have a look. See if we can get rid of all this very quickly. Okay, so our method 2, let's see what you've written as your solutions. So I can see a few of your solutions. One of us have written that we can, let me just read that out properly. Just expand on that. There we go. Right. So some comments. It says, "Wow, very interesting." So thank you very much. So one of us have said that maybe we can take the whole away first, and then we can take the fraction away. That's a really good one as well. So we've got 3 wholes. 1, 2. They should all be equal, but it might not be great with my pen. 3 wholes, and we've got a quarter. Okay, so here's a quarter and 3 wholes. Okay, and so some of us saying take the whole away first. So I'll take this whole away, got rid of that, and then take a half away. Okay, so let's take a half. Let's take that away. What are we left with? We're left with 1 whole, a half, and a quarter. And if this was literally a piece of paper and we just connected this here, then we can see that that's going to be 3 quarters and a whole. So this is equal to 1 and 3 quarters. So something really complex, 3 and a quarter take away 1 and a half. The complex part is the fact that you've only got a quarter here and we're taking away a half. That's what makes it a bit more complex. And so in this example, we've literally taken a few seconds, we've literally taken a few seconds to solve a question that a lot of children might struggle with. Fractions, I don't know, we've got, it's amazing that we've got so many people from different countries in this webinar, all around the world, which is brilliant to see, amazing. And it's great that we can share ideas like this with you all. But we can see, I think no matter which country you're from, children do find fractions quite challenging in most countries. And therefore, how do we support them? How do we get them to master fractions? And one simple way is to be able to illustrate, draw pictures of what we're doing, okay? Using rectangles rather than circles, because we've got I don't know about your country, but in England, we've got this fascination with fractions and food, so there's always cakes or pizza, right? It's always the case. But pizzas and cakes makes life a bit more hard when it comes to sharing odd numbers like thirds or fifths or sevenths, for example. And so rectangles are brilliant for that. It's much easier to do that. And if you've got square paper, then it's also easy to do it in that way as well. Okay, so let's have a look. Equivalent fractions. Hopefully you can see, like in this example, we've got pizzas here, right? It's perfect for this type of equivalent fraction. You can see that this is a half of a pizza here. You can see that's half of a pizza. And then we can see that we can actually cut the same pizza into 4 equal parts, and we can still have half of the pizza, but we can call them quarters. So this is 2 quarters, for example. And this kind of concept is developed more, back to rectangles again, with a fraction wall. So you might have a fraction wall like this in your school, okay, on your posters and your walls. And these are really brilliant way to see how a whole can be cut up into different sections like halves, thirds, quarters, tenths, for example. But then we can see how this number of tenths, 5 tenths, is equal to a half. And that is again shown in our books, and we have lots of ideas and very visual ideas for you to work with. So life for you as a teacher, sometimes we really are searching from the internet, from our colleagues, brilliant ideas we can use for our lessons. And that's where the books really come in, because there are some fantastic ideas in the books which you don't have to search anymore. It's just there for you. So our planning life is a lot easier when you've got these suggestions in front of you. Here's like one example I want to use from the equivalent fractions lesson. Okay, so I did this with my son. I think it was last week, end of last week. Excuse me. At the end of last week, and we looked at halves and quarters at first, and then we looked at other fractions later on. So he looked at the fact that this is a whole, okay, and so is this. And he realized that this is a half, but also I can cut my whole into 4 equal parts and see that 2 half is equal to 2 quarters. Then I said, well, are there any other ways that we can have a half, but not just one part of a whole? So you've got 2 parts of a whole there. And then he started to play around with paper, just like this. Play around with paper, and then he realized that a half is equal to 4/8, half is equal to 3/6, and so forth. Okay. And then he noticed something as well. So one way to differentiate is, do you notice anything about your results, okay, that you've got in front of you? He noticed, and he said, he wrote this down. I noticed that the numerator is always half of the denominator when it's equivalent to a half. So half, for example, 1 and 2, 2 and 4, 4 and 8, 3 and 6, 8 and 16. These are the numerator is always half of the denominator. So one way to differentiate is to figure out some generalizations. Oh, halves. Oh, the numerator is always half of the denominator when it's a half. So that's one way to quickly realize it's a half. And then he wrote an explanation as well to find equivalent fraction. He realized that when you fold the paper in half, if you've only got one piece, when you fold it into 2 equal parts, smaller parts, then you have to do that for the other pieces as well. And that's when he realized that we have to multiply both the numerator and denominator by the same amount to get an equivalent fraction. I didn't want to tell him that. I want him to work that out by looking at the piece of paper, looking at his images and so forth. And so we talked about 4 ways of modeling halves as an example. So these are other ways that we look at in our books. For example, division, and this goes into more depth in finding a fraction of an amount and so forth. And you can see how division here, you've got 2 pairs of apple, and you want to share amongst 3 people. How do I do that? Maybe I can share 1 piece at a time. So this 1 piece cuts into 3 pieces. This 1 piece cuts into 3 equal pieces again, and we can share that out equally. Each friend gets 2 of these pieces. So when we had 2 apples, we divided it amongst 3 people. Each of my friends received 2/3, and then we make that link between 2 divided by 3 and 2/3, and you can see that here and so forth in the questions. So lots of different kind of ideas for you to think about. And as I said, remember what we said before, representing a half using 4 different models. It's all in the book. So sometimes when we're planning ourselves, we might forget a few things. So we need some sort of structure that allows us to do that. So let me quickly have a look at questions. We've got 1 or 2 questions come up here. What it says, so Liz says, Lizzo says that, what about money? If you can explain, maybe if you can write a question at the end of the Q&A session, explain what you mean by that. What about money? What about money? Tell me about money. So we would all like to know about money, right? So can you elaborate a bit more on that? That'd be great. So as we're kind of nearing to the end of our session, so go through a few other things with you. So questions that really make us think, things like which is larger, 1/4 or 1/3. So we want our children to be able to reason as well. So pictures allow them to reason. So if we think about, we've got a hole here, class, and a hole here, same hole here, and one whole has been cut up into 4 equal parts, and one whole has been cut up into 3 equal parts. One is highlighted here, 1/4, 1/3. And so which is the larger amount? 1/3 is larger, right? Because a lot of kids, they think the larger amount will be the quarter because 4 is a bigger number, right? But so visually seeing fractions allows our children to master fractions because they can start reasoning. They can think, oh, actually, I've got a whole. If I cut that into 4 equal parts, and I've got the same whole, if I cut that into 3 equal parts, the 3 parts are going to be bigger than the 4 parts, right? And so the 1/3 is going to be bigger. Then they can start making generalizations like, oh, if the smaller the denominator, if the numerator is always 1, the smaller the denominator, the larger the fraction. So these are kind of things that I want my children in my classroom to be able to think about and to process, to see, and then to say, and then to write as well. And again, word problems are really good at doing these sort of things. And you can see how we've kind of developed the word problems here in this word problem. So lots of word problems in our books. Don't forget that though in this webinar interface, it's quite hard for me to do, but I've tried with like having paper in front of you. So in this question, we took this. In this question, it's Toby and Han share a pizza. Share a pizza. Toby eats a sixth, and then Han eats a half. So this question was a similar type of question. I've written here that Yahya, he has a quarter. So this is a quarter of, I don't know, a cake, and then Ruqayya has not a quarter, but she cuts the rest of the cake into 6 equal parts. You can see the 6 equal parts, and she takes 3 equal parts. Who has more, Yahya or Ruqayya? And so this question, the class are expected to use the piece of paper and try to model that out. So we've got quarters. So he's drawn out and folded the paper in quarters. Then he's also made the rest of what's remaining into 6 equal parts and given 3 to Ruqayya. And then he had to realize that actually the three parts are equal to 3/8, and the 2 parts, or the quarter actually that Yahya had, the quarter is equal to 2/8. And so you can see that 3/8 is larger than 2/8. So this is something that when you're teaching maths, try to use concrete materials first. So we follow a process called a CPA process, concrete pictorial abstract process, CPA, okay? Concrete pictorial abstract process. That means that we start off with concrete elements first before moving on to pictorial representations, like the pictures that we've drawn out here, or some of the pictures that we've drawn out earlier on as well. And then we look at the abstract, or we don't look at the abstract separately. We look at the abstract with the concrete. We look at the abstract with the pictorial. Here's a question that I want you to work out. Maybe this is our penultimate question before we go into a Q&A session. Here's a question I want you to work out. 2/3 divided by 2. Talk to your colleagues or someone next to you, or write down your solution to this question. Think about how you'd solve this question. I'll turn my mic off now and give you a minute to try to solve this question. Okay, class, I think we've had some time. Some of us have given us some solutions. Some of us have said 2/3 times a half. Some of us have said 3/4. Oh no, sorry, 2/3 times a half. Some 2/6, which is a third. And some of us have said 2/3 is just 2 lots of thirds, and so forth. Okay, so one of us have said I will make 2/3 as 4/6, where denominator is even number. When the number, divide the paper into 6 parts. Out of the 4 parts, we can select 2 parts as a half. Okay, right. So this is an interesting thing. Okay, because there's a few things I want to go through with you here. So let's have a think about this. Okay, if I said to you two cars divided by 2, that's equal to 1 car. Or 2 sweets divided by 2, 1 sweet. Fractions is a lot about language as well. If we think about the denominator as a noun, like a car or sweet or whatever you want, whatever you're thinking about, okay, pizza, whatever if you're hungry, you can have something else, okay. If you think about it as a noun, 2 cars divided by 2 is equal to 1 rather equal to 1. So when we think about thirds, 2 thirds divided by 2, 2 cars divided by 2 is 1 car, 2 thirds divided by 2 is 1 third, okay. So if we have a look at this, if we draw a picture of this as a circle or a rectangle, I prefer rectangles, it's easier for me. I've got 2 thirds, these are my 2 thirds. Might shade them in. If I have 2 of something, if I divide that 2 by 2, sorry, then I've got 1 third left. So 2 thirds divided by 2 equals to a third. That was a bit more easier because the noun, how many we have here, how many equal parts we have, can be easily divisible by 2, right? So that's something I want us to think about for our next question. 2 thirds divided by 3. This is more challenging now. Visually, I can see 2 thirds quickly, and I can divide the 2 pieces by 2 is easy. But what about 2 thirds divided by 3? Have a go at that. This is possibly our penultimate question, our final question before we go into a Q&A session, or before I go into one more thing, and then we're going to go to a Q&A session. So have a think about that. Tell me what you have as your answer. We've got quite a lot of attendees here, so please feel free to get involved. Don't be shy. If you don't understand something, feel free to ask questions. Don't worry, no one can read your questions. Okay, so I'm going to quickly have a look at the questions. Oops, there we go. Right. So we've got quite a few solutions here. Using pictures simplifies the problem. Yeah, Naisha, I think you're right. You know, using pictures tries to simplify the problem, but we want it to be simple so that our kids get it. And then once they get it, then we can look at the abstract and see where the links are, how the abstract is connected to the pictures. Okay, so we've got lots of answers, 2 ninths, 2 ninths, 2 ninths, okay, 2 thirds times 1 third. Okay, great. So here's the thing, okay, so let's have a look at what you have written and what I'm going to go through. So we've got 2 thirds. So here are my 2 thirds. Oops, not the most beautiful thirds I could have drawn, but here we go, there's a better one there. Right, so I've got my 2 thirds, okay, here we go. This is my third, that's my third. Let me do that again. I've got my thirds, wrong page. These are my thirds, 2 thirds altogether. This is 2 thirds. I'm dividing my 2 thirds by 3. Now, previous question, dividing by 2 was simple because I had 2 pieces. I can divide by 2 straight away. But now I have 2 pieces. I have to divide by 3, which makes things a bit more complex. How am I going to do it? I don't know at the moment, right? But what about if I just had one piece? If I just had this one piece, then I could easily share that one piece into 3 equal pieces, right? And so can I do that for the second piece as well? That's great. Now I've got 6 pieces. Now I've got 6 pieces. 1, 2, 3, 4, 5, 6. I've got 6 pieces. And now I can share 6 divided by 2, or 3 rather. I can share 6 divided by 3 quite easily. 6 divided by 3 is going to be 2. 1, 2. 6 divided by 3 is 2. So these are the two pieces I'm going to be sharing, or 2/3 divided by 3 is going to be those two pieces. But what am I going to call those pieces? That's the challenging part. So class, let me ask you a question. Are all of these pieces in the picture in front of you, are they all equal? And you can see clearly they're not, right? You've got this one big piece here, and the rest are small. So what did we talk about fractions? When we talked about fractions, our first questions to you, class, our first question was, what is a fraction? Fractions are equal parts of the whole. That word equal is so important, as I mentioned to you, right? If we don't emphasize on the word equal every lesson when you look at fractions, then what happens is we start to make mistakes here. So because they're not all equal, class, is there a way, this is the question I would ask my children in my classroom, is there a way I can make all of those pieces equal? And typically our children will say, yeah, all you have to do is do something like this. Ah, great, now they are all equal, right? So I know now I've got 3, 6, I've got 9 pieces altogether. These two pieces are 2 9ths. So 2/3 divided by 3 is equal to 2 9ths. This is equal to 2 9ths. Is that right? Okay, let's have a think about, class, what we did. We had 2/3, but then we cut them into smaller pieces. And what do we have? How many pieces do we have? 1, 2, 3, 4. 2/3 is equal to 6 9ths. Is that okay? 2/3 is equal to 6 9ths. And that's where we have these smaller pieces. So 6 9ths, now 2/3 is equal to 6 9ths. Now we can divide 6 pieces by 3 quite easily. We've got 6 pieces, 6 divided by 3 is equal to 2. And so I've got 2 9ths. So what we did using the picture was actually just find an equivalent fraction that could be easily divisible by 3. So 2/3, 2 is harder to divide by 3, but 6 is easy for us to divide by 3. And so 6 divided by 3 is 2, but now we don't have the same number of pieces. We have 9 pieces altogether. So that's called 2 9ths. So hopefully you understood that example. It's a lot easier when I'm in front of you in a seminar somewhere. I know we're traveling to quite a few places. And I think this month we're going to the Middle East, and hopefully we'll be going around other places around the world to visit and to deliver seminars. So if you are in the region, please do come over and visit our seminars. I'm going to finish off with just a reminder to you, as we've kind of got 2 minutes left, to think about when you're teaching a class, think about the concrete aspects. How can I use concrete materials? I typically use paper for fractions to show and emphasize this idea that I'm going to be teaching. Then I can use pictorial representations, and together with the concrete pictorial, I can show them the abstract so that they can make sense of it, rather than just me telling them to memorize, because that's really challenging. Seeing maths, remember, helps us to master maths, okay, and build a mental picture of what we're trying to teach. So I'm going to stop there for our CPD, but there are Q&A sessions that we have. I've got plenty of time for you to ask any questions that you have in your mind. So I'm just going to read some questions out if we have time. Let's see. Okay, so okay, let's see. Very interesting. Thank you. Try to change. Okay. Using simple pictures. Sorry, I'm just going to go down. Thank you. Okay. Oh, thank you for the emphasis on equal parts. It is really common to forget that. Okay. Thank you, Naisha. It is common to forget that. I know. Totally agree. But without that part, then I think a lot of fractions, including addition and subtraction of fractions, becomes challenging. Thank you. Is there any other sessions for other topics as audio conference? Marina, I'm sure there are plans for other topics coming up. you'll have to ask Raina. Maybe just give her a quick email. I think she emails you to confirm your attendance for this session, and when she gives you a certificate, you can ask her questions about other topics. Where does one get the book that you were using in the presentation? The book is the Max Maths series of books. Raina will be able to tell you where to purchase them in your region if you just give her a quick email, or maybe she can contact you somehow. Thank you from Charu. Thank you very much for attending. Thank you for different approaches. No problem at all, Arshia. Thank you, Marina, for attending as well. Very informative session. Thank you. You're welcome, Naisha. Thank you. It was really very informative. Thanks, Mrs. Shilpi. Thank you, sir. Looking forward to our next webinar. Thank you, Mustafa. My students had difficulties about how to divide two fractions. How we have a rule. Dividing two fractions, yeah, it is challenging, Lee. And one aspect is, I suppose, trying to use basic instruction about dividing. So we might look at how, instead of focusing on fractions first thing, Lee, what I might do is I might say something like 3 divided by a half. So what we're trying to really get to is how many halves are there in 3. So we can look at 3, look how many halves there are, and realize that when we divide by half, for example, is the same as multiplying by 2, because we're saying how many halves there are in 3, how many halves there are in 4, how many halves are there in 5. We can keep going and seeing a link between dividing by half is the same as multiplying by 2, and then using that example to then look at when we're dividing a fraction by another fraction, we can use that rule, but this is why the rule works. Very important, excellent presentation. Thank you, Anazette. Hopefully we'll see you in our next session, or hopefully if you are in the region that we're going to be delivering live seminars where we're physically there, I will be really happy to see you all, and please do come over and speak to me. I'll be really happy to speak to you too. Thanks a lot, Mrs. Ginny Sharifa. Thank you for attending, Sharifa. Thank you so much. Really kind words. Thank you so much. It's been really a pleasure to deliver to you this webinar, and hopefully we'll see you in future webinars. Raina?
Yeah, great. So just want to say thank you so much to Mohi for a wonderful session. It's so nice when our teachers are engaged, they're active, they're participating. And of course, this is why we deliver webinars, because they are global and it means we're sharing good practice. But in addition to that, we have a Singapore Maths consultant here delivering the sessions to really support you with those key questions, particularly around fractions. When you do reply to emails, if you do have any questions, please do let us know what sort of topics you'd like to cover in future webinars, because we are hoping to do these termly as of January 2020. So do get in contact if you have any questions. Thank you so much for your participation. We know how difficult it is to get time away from lessons and students. And thank you so much to Mohi as well for an excellent webinar. And hopefully we'll look forward to seeing you again in the coming year. And as I said, CPD webinars certificates are available. Please do contact us, and hopefully we will be able to send those through to you as well. So for now, thank you so much, Mohi. Thank you for everyone joining, and look forward to seeing you in our next webinar. Thank you, everyone.